Thank you. Thank you very much. Mr. Chairman, dear participants, our work is next phase application of fuzzy logic of Lutfi. Do you know that since 1965, this theory actively developed in the world? Currently, the automation of agriculture processes is carried out at an accelerated pace, including through the introduction of elements of artificial intelligence, which allows farmers to significantly reduce cost and increase profits by increasing yields. In particular, existing systems of the IoT platform, International of Things platforms, processing data from sensors can provide the farmer not only with information about crop damage, but also offer ways to solve the problem, calculate the required amount of pesticides, the optimal time for treating problem areas, assess the state vegetation, and suggest preventive measures. These considerations dictate the main essence of our research, which is related to the provision of forecasting tool for making agriculture decision. Hello. In the Zangilan district of the East Zangezur economic region of the Republic of Azerbaijan, about years ago, liberated from Armenian occupation, on a designated plot of land, Sinam Ltd company implemented its IoT platform based intelligent applications that provides round-the-clock monitoring of soil, meteorological conditions, as well as the condition of cereal groups, taking into account the impact of insect pests. Based on the collected historical data, the Sinam system application provides users with operational information, including in the form of graphs reflecting the dynamics of change in humidity, crop conditions, terrain, meteorological situation. In this case, the ultimate goal is to create an option for conducting a comprehensive analysis of historical data and developing approach time series model for predictive growth yields. The object of our study is the ground humidity time series covering the set of historical data. This is only a single tool. Sinam IoT platform aggregate many tools. This is only one tool for forecasting humidity process. Do you know time series? Three time series. Middle time series is the average of two time series, and we can say that any sensor reading date can be described as fuzzy sets because any historical data is semi-structured, weakly structured data, because we want to apply fuzzy technology to modify, to forecast this time series. Our solution. To assess the dynamics of change in soil humidity in a specific group area, a further approach to forecasting a time series compliant from sensor reading is proposed. A method for falsifying historical data based on sensor readings relative to ground humidity is proposed. It's very main step in our application, because correct falsification of historical data generate is a finish correct result. An acceptable number of correlative criteria for assessing historical data has been established. It's possible. It's necessary for correct provide procedure of diversification. A predictive model has been developed to predict ground humidity. This is now three base problem. Because the ground humidity indicator is established by the usual arithmetical averaging of sensor readings from several sections of the group area, each of its value xt at time t will be considered as weakly structured historical data, which can be interpreted in the form of fuzzy sets, AK. Any data described by appropriate fuzzy set AK, where mu is membership function, of fuzzy sets AQ. In this case, the fuzzy sets AK is an evaluation concept and is used as a qualitative criterion for assessing sensor readings. The main sense of our approach, if we cannot find regularity between crisp number, we falsify any number and operate with fuzzy sets. Fuzzy logic of Rzayev provides this regulation between fuzzy sets. Sorry. For each specific time series, the number of qualitative assessments criteria is set step by follows. This is necessary formula to find optimal number of qualitative criteria to estimate any historical data. In the finish, we find optimal number M. I don't see formula. We find optimal number M. To falsify any historical data, we applied trapezoidal membership function. Do you know that exist many forms of membership function? For example, triangular, Gauss type, Bell type function. Trapezoidal membership function we used for falsification historical data. As a result, we found for each sensor reading data appropriate trapezoidal membership function. After falsification, our time series can be described by in the term of fuzzy sets. Uh, this column demonstrates fuzzy time series. This is uh, historical data. We cannot pattern into the fuzzy time into the time series. We cannot find pattern between this number. After fuzzification, we can this process in correct order. Next table demonstrate first order time series predictive model. Applying fuzzy logic technique methodology, we find predictive number for our time series. This is predictive number. So, first step, we fuzzificate a number, then we find optimal number of criteria to estimate every historical data. Then we applied fuzzy procedure to find internal relations between number. Then we use few rules to obtain final results in the form of predict number. This is first order time series. This is second order time series predictive model. And we interpreted our two table predictive models by graphics, and we can see that famous statistical criteria, mean square error, MCE, mean average percent error, mean percent error is very suitable for our prediction model. MCE1 is for predictive model, first order predictive time series, and MCE2, for example, to second order time series predictive model. What we obtained? We obtained adequate model for time series, for exist time series. We know as can control any situation in the year, in the any area. This is model. Just a moment. This model demonstrates only one sensor data, one sensor reading data. Diversificate this model in another sensor readings can create information decision-making support system for agriculture area. In conclusion, The result presented in the article in my report is only one minor fragment in the general methodology for processing sensory signals carried out as part of application of IoT technology in precision agriculture. This or similar methodology has the potential of enable an intelligent IoT platform despite being overshadowed by other aspects of IoT technology, such as communication architecture, sensor technology, and power management. The approach facilitates this creation of tools for monitoring the current state of groups and controlling the growing environment and is aimed at increasing the yield of the group as a whole. By anticipating undesirable situation, one can permanently maintain a high level of care for the group area. I'm finished. Thank you very much. Thank you very much.